people hear the name Bugatti, they usually think about extreme luxury, unbelievable speed, and a car that feels like it belongs in another world. A Bugatti Chiron is not just a car. It is a symbol of engineering power and money. Most people assume that everything inside it is specially made only for Bugatti, designed from scratch, and built in a secret way that no other car in the world can match. But when you look deeper into how such a car is built and repaired, a very surprising truth starts to appear. Many of the parts inside this hypercar are not unique at all. In fact, they come from other well-known car brands that most people see every day on normal roads. This idea sounds shocking at first, because it breaks the belief that a multi-million-dollar car must have completely exclusive parts. But in real engineering, even the most advanced machines often rely on shared components. Car companies, even luxury ones, are part of larger groups or supply chains where parts are designed once and then used across many different models. This helps reduce cost, improve reliability, and make repairs easier. In the case of Bugatti, which is part of the Volkswagen Group, many shared parts exist between brands like Audi, Porsche, Lamborghini, Volkswagen, and even Mercedes in some supply cases. So when a damaged Bugatti is rebuilt or inspected closely, technicians sometimes discover that certain components have part numbers that match cheaper cars. This does not mean the Bugatti is cheap, but it shows that even the most expensive machines rely on practical engineering decisions. The shocking part is not that parts are shared, but that people usually never think about it. They imagine a hypercar as something completely separate from normal cars, when in reality, it is still built using real-world manufacturing systems. Once you understand this, the idea of 8 different car brands inside a Bugatti becomes less like conspiracy and more like a lesson in how modern automotive engineering actually works. It is a mix of exclusivity and practicality, where high-end design sits on top of shared mechanical foundations. This makes the story not just about a car, but about how the entire automotive industry is connected in ways most people never realize. To understand why a Bugatti might contain parts from other car brands, we need to understand how modern car companies actually operate. No car manufacturer builds every single tiny component from zero anymore. Even companies that make extremely expensive vehicles rely on suppliers and shared engineering platforms. The Volkswagen Group, which owns Bugatti, also owns brands like Audi, Porsche, Lamborghini, Bentley, and Volkswagen itself. Because of this, many systems like electronics, sensors, airbag modules, and even some mechanical parts are developed in shared engineering departments and then used across multiple brands. This approach is not about lowering quality. Instead, it is about controlling reliability and performance. If one high-quality part is already tested and proven safe in millions of cars, it makes sense to reuse it in other vehicles rather than designing a completely new version from scratch. For a hypercar like Bugatti, this becomes even more important because it needs to be extremely reliable at high speeds. A single failure in a safety system like airbags or crash sensors could be dangerous, so using already tested components can actually increase safety. Another reason is cost and production efficiency. Even though Bugatti cars are extremely expensive, they are still produced in very small numbers. Creating completely unique parts for every system will make the development costs incredibly high and inefficient. Instead, engineers choose a mix of custom-built components and shared high-performance parts. This creates a balance between uniqueness and practicality. It is also important to understand that shared parts do not make the car less special. Most of the uniqueness in a Bugatti comes from its engine, chassis design, aerodynamics, and overall performance engineering, not from every small screw or sensor inside it. The shared components are usually hidden deep inside systems, where they perform standard but critical functions. So when someone discovers that a part in a Bugatti matches something from a Honda, Volkswagen, or Mercedes, it is not a sign of weakness. It is actually a sign of how interconnected modern automotive engineering has become. The real surprise for most people is not the existence of shared parts, but the fact that they were never aware of this system in the first place. It changes the way we think about luxury cars and shows that even the most elite machines in the world are still built on a foundation of common engineering principles used across the entire industry. One of the most surprising discoveries in this Bugatti story is the airbag system, especially the passenger airbag that appears to come directly from a much cheaper car, the Audi A3. At first, This sounds almost unbelievable because airbags are one of the most important safety systems in any vehicle, and people assume that a hypercar like Bugatti would use a completely unique and specially engineered version. However, when the part was removed and inspected closely, the part number matched exactly with the airbag used in an Audi A3 model produced between 2013 and 2022. This is not a rough similarity or a shared design idea. It is the exact same component. This kind of discovery immediately raises questions for anyone who believes luxury cars are built from completely exclusive parts. The reality is that safety systems like airbags are often standardized across large automotive groups because they must meet strict international safety regulations. If a component has already been tested, certified, and proven to work safely in millions of vehicles, it becomes a strong candidate for reuse in other models. In this case, the Audi A3 airbag is not cheap in quality. It is simply widely used and mass-produced, which lowers its cost compared to low-volume specialized parts. What makes this discovery even more interesting is not just the airbag itself, but how it integrates into a hypercar environment. Engineers had to ensure that the airbag cover and deployment system still function perfectly within the Bugatti's unique dashboard design. This required careful measurement, design adjustments, and sometimes custom modifications to ensure safety performance remained exact. Even though the core airbag unit is shared, the way it is installed and integrated into the Bugatti interior is still highly precise and engineered for that specific car. This shows an important truth about automotive design. The magic of a hypercar is not always in every single part being unique, but in how those parts are combined, tuned, and engineered to work together at extreme performance levels. So while the idea of an Audi A3 airbag inside a Bugatti may sound shocking at first, it actually reveals how global car manufacturing works behind the scenes, where safety, efficiency, and engineering logic often matter more than exclusivity. Another important component in this investigation is a steering wheel airbag ignition system, often called a pyrotechnic squib. This is a very small device, but it plays a massive role in safety. Its job is to trigger the airbag explosion mechanism during a crash, ensuring the airbag deploys at the exact right moment. Without it, the airbag system would not function at all. In the Bugatti Chiron, this squib was found to match a part used in an Aston Martin vehicle. Again, this is not a similar design or inspired version. It is the same part number, meaning the exact same component is shared between two very different brands. This might seem strange because Aston Martin and Bugatti are seen as separate luxury worlds, but in reality, many automotive suppliers work across multiple brands. These suppliers produce highly specialized safety components that meet strict industry standards, and once a part is certified, it can be used across many different cars. The reason for this is simple. Safety components like squibs must be extremely reliable, and it makes sense to use proven technology rather than reinventing it for every new vehicle. In a hypercar where performance is extreme and conditions are intense, reliability becomes even more important. Even a fraction of a second delay in airbag deployment could make a difference in safety outcomes. So using a trusted and already tested squib is actually a logical engineering decision. What makes this discovery interesting is a contrast between perception and reality. Most people imagine that every part inside a Bugatti is custom-made and exclusive, but in reality, some of the most critical safety systems are shared with other manufacturers. This does not reduce the value of the car. Instead, it highlights how deeply connected the automotive industry is. Even luxury brands depend on shared engineering knowledge and supply chains to ensure safety and performance standards are consistently met across all vehicles. Whether they cost £20,000 or several million pounds, one of the most talked about parts in this entire Bugatti rebuild story is the radiator system, especially because it connects a world-class hypercar to one of the most common everyday cars, the Honda Civic. At first, this sounds almost impossible. A Bugatti Chiron has a massive 16-cylinder quad-turbo engine producing extreme heat, while Honda Civic is a normal family car designed for everyday driving. Yet, when engineers and builders looked closely at the cooling requirements and physical structure of the radiators, they found something surprising. The Honda Civic radiator cores had a very similar heat transfer capability when compared to the original Bugatti design. This does not mean the parts are identical in size or appearance, but the performance characteristics, how much heat they can remove from the engine, were close enough to make them usable with modifications. The key idea here is that radiators are not judged only by brand or luxury level, but by physics. They work based on surface area, airflow, and material efficiency. If two different radiators can achieve the same cooling effect under similar conditions, then they can theoretically serve the same purpose with adjustments. In this case, custom end tanks and fittings were created to adapt the Honda Civic cores to fit the Bugatti system. This is where engineering creativity becomes important. Instead of relying on a factory-made Bugatti radiator, the team effectively rebuilt the cooling system using a proven, widely available core and then customized it to handle extreme performance requirements. The result was a system capable of keeping the W16 engine at stable operating temperatures even under load. This part of the story is important because it shows that performance does not always depend on exclusivity. Sometimes it depends on understanding the science behind the part and finding equivalent solutions that meet the same functional needs. The shock factor comes from the contrast between expectation and reality. People assume a hypercar must use completely unique cooling systems, but in practice, engineering solutions often come from adapting existing technologies rather than reinventing them entirely. As the investigation continues, a pattern becomes clearer. Many of the parts found inside the Bugatti Chiron come from within the Volkswagen Group itself. This includes components like the secondary air pump and crash sensors, which match parts used in Volkswagen and Porsche vehicles. This is not accidental. It is a result of how large automotive groups operate. When multiple brands are owned by the same company, they often share platforms, electrical systems, and components to improve efficiency and reliability. For example, the secondary air pump found in the Bugatti is the same type used in certain Volkswagen models, where its job is to reduce emissions during cold starts by pushing fresh air into the exhaust system. Even though the Bugatti Chiron is a hypercar with extreme performance, it still needs to meet modern environmental and safety regulations, which means it requires the same basic emission control systems as regular cars. Similarly, crash sensors used in the Bugatti were found to match Porsche components. These sensors play a critical role in detecting the direction and force of an impact, helping the airbag system decide how to deploy correctly. Because safety systems must be extremely reliable, manufacturers often prefer using proven sensors that have already been tested in large numbers of vehicles. The Volkswagen Group benefits from this shared approach because it reduces development time, lowers costs, and ensures consistency across brands. From an engineering perspective, this is not a weakness. It is a strength. It allows even high-performance vehicles to rely on systems that have been tested in real-world conditions across millions of cars. The surprising part for most viewers is not that shared parts exist, but that they exist inside a vehicle with such an extreme price tag. It challenges the idea that luxury always means complete uniqueness. Instead, it shows that even the most advanced machines in the world are built on shared foundations of engineering and industrial efficiency. One of the most surprising discoveries in the Bugatti Chiron rebuild is the Pyrofuse system, a small but extremely important safety device that sits quietly near the battery. A Pyrofuse is designed to cut electrical power instantly in the event of a serious crash. When the airbags deploy, this device fires and physically disconnects the battery from the rest of the car's electrical system. This helps reduce the risk of fire and protects both passengers and the vehicle's sensitive electronics. What makes this discovery so interesting is that the Pyrofuse found in the Bugatti Chiron matches a unit used by Mercedes-Benz. This is not part of the Volkswagen Group ecosystem, which makes it stand out even more. It shows that even a hypercar built under one of the world's most advanced automotive groups can still use safety components sourced from outside manufacturers when those components meet the required standards. In engineering terms, this is not unusual. Safety systems are often chosen based on reliability, performance history, and availability rather than brand identity. Mercedes has a strong reputation for safety engineering, and their Pyrofuse systems are widely respected for being fast, reliable, and consistent under extreme conditions. From a design point of view, it makes sense to use a proven system rather than creating a completely new one for a very low-volume vehicle like a Bugatti. Even though the Chiron is a multi-million-dollar car, it is still produced in extremely small numbers compared to mass-market vehicles. Developing every single safety component from scratch would be inefficient and unnecessary when high-quality solutions already exist. The important takeaway here is that luxury and exclusivity do not always mean unique parts. Instead, they often mean carefully selected, highly optimized systems that come from the best available sources. The Pyrofuse is a perfect example of how critical safety decisions in automotive design are driven by performance and trust rather than branding. For most viewers, it is surprising to learn that something as advanced as a Bugatti relies on a Mercedes component. But for engineers, it is simply a smart and practical decision. Another unexpected discovery in this investigation is the fuse board system, which plays a central role in controlling how electricity flows through the Bugatti Chiron. The fuse board is essentially the brain of the car's electrical distribution system, routing power to different components and protecting them from overloads. When the damaged unit was removed and analyzed, it was found that its design closely matched the fuse board used in the Lamborghini Gallardo. Both Lamborghini and Bugatti are part of the Volkswagen Group, which explains why such a connection exists. Within large automotive groups, many electrical systems are standardized across different brands to simplify engineering and production. This means that a fuse board designed for one car can often be adapted for use in another, even if the two vehicles are very different in performance and price. In this case, the Lamborghini Gallardo fuse board was able to function correctly inside the Bugatti Chiron after being installed and connected. The system recognized it, accepted it, and operated without issues, proving that the underlying architecture is compatible. This is a powerful example of how shared engineering